Good evening or afternoon or morning. I'm not really sure where you are at this point. But this is my first attempt at a screencast for human biology. Today we're going to start with Chapter 12, the skeletal system. Now I know we went over this, the first portion of this lecture a few weeks ago prior to our spring break and all the craziness that has now happened. But I'm going to start here and go through this. I'm going to break each chapter into 2 or 3 different casts, only because they get too big to upload to the YouTube page that I created just for this reason. So in any event, here we are and here we go. So the skeletal system is very important for a number of different reasons. It keeps us, it gives us our shape, it gives us support, it gives us some protection, and a variety of other things. Think about where you would be without your bones, or even if some of your bones were broken. All right, you've got obviously very large difficulties ahead if that is indeed the case. Oops, nope, that's not it. So there we go. So what are the functions of the skeletal system? Well, there are 5 major functions here. First, it supports the body. All right, think about where you would be without a skeleton. You wouldn't be able to stand, move around, do a number of different things, but essentially support. It gives you your shape. Secondly, it protects the soft body parts. Think about your brain. Okay, right in there, protected by a very hard skull. Okay, as we learned in the unit on blood, the skeletal system is responsible for the production of blood cells, red blood cells, white blood cells, and platelets to be specific. Right, all of them found developing from the stem cells in the red bone marrow. It stores minerals, specifically calcium and phosphate. And as we'll learn, calcium is exceptionally important in muscle contraction, nerve impulses, and a variety of things. But the bones also store fat, which is something that most people don't realize. And finally, it allows for movement by attaching muscles. All right, when you flex your muscles, all right, this is a direct result of the levers that are being used pulling one muscle toward you, or another muscle away from you. All right, and the muscles are using the bones as levers. So what is the anatomy of a long bone? All right, let me move this out of the way a little bit here. There are several major portions in a long bone. The diaphysis are shafts of bone that are found in the middle here. So this section that you find here, this is the diaphysis. Actually, it would extend a little bit further down than that. It's made of very compact bone. You can see very solid in here, and filled with yellow bone marrow, which is, as you can see here, the place where we store fat. The epiphyses are the 2 ends of the long bones, here and here. All right, the one on the top is cut open in this diagram so that you can see, whoops, wrong way. You can see that it's filled with spongy bone. And it is filled with the red bone marrow, which is where we find the stem cells producing red blood cells. At the very end down here, you find articular cartilage. You can kind of see it on the top here. And that's the cartilage that exists between 2 long bones, where we have a joint so that the bones aren't rubbing directly on one another. Finally, you've got the periosteum, which is kind of like the skin of the bone, living outer tissue that covers the bone. And last but not least, fibrous connective tissue that connects the bones are called ligaments. And we'll get to that a little bit later on. I don't know why that went backwards. Anyway, so more detail on bone. All right. What is shown here are two sections. You can see spongy bone in this area here and compact bone over here. Compact bone is actually composed of tiny little tunnels called osteons. An osteon has a central canal and is surrounded by layers of compact bone. Now, the central canal contains blood vessels, nerves, everything that you would expect to find in a living organ or organism. And in each of these little, see the little dark mark right there? And I'll circle a few. There's one here, there's one here, and so on. Those are called lacunae, little chambers. And inside the lacunae, and you can see it here, is a bone cell called an osteocyte. Okay, and these are either building up the calcium phosphate matrix or breaking it down. On the left-hand side, you see the spongy bone, and this is made of kind of bony plates, and this is where you find the red bone marrow. Now, at the ends of bones and in other places in the body, you find cartilage. Cartilage is another kind of connective tissue, but it's much more flexible than the typical calcium phosphate matrix that you find with bone. It's categorized in three different categories. You've got hyaline cartilage, fibrocartilage, and finally elastic cartilage. Hyaline cartilage is the most common cartilage. You find it at the end of long bones, in your nose, at the end of your nose here, the ends of your ribs, your larynx, in other words, your voice box, and in your trachea. Fibrocartilage is much stronger than hyaline cartilage, and you find that in the discs between your vertebrae. If you've ever heard of somebody slipping a disc, it's because there are two vertebrae next to each other, and there's a cartilage disc in between. And if that disc moves, it pinches the nerves that are supposed to be coming out of it. You also find fibrocartilage in the knee, because the knee is one of the joints that takes the most abuse in the human body. And finally, elastic cartilage is found in your ear flaps, the epiglottis that covers up your trachea when you swallow food, and it is far more flexible than hyaline cartilage. So you've got your typical average American cartilage in the hyaline, you've got fibrocartilage, which is very strong, and then elastic cartilage, which is much more flexible. Now, how does bone develop? Well, in terms of your work from developing from a fetus into an adult, there are two different ways that bone can form. You have intramembranous ossification, which is the development of bone between sheets of fibrous connective tissue. In other words, you've got bones forming one layer on top of another layer on top of another layer on top of another layer, and they kind of compress, they squeeze together and eventually ossify or become bone. And that's typically found in flat bones, like the bones that make up your skull. Not to say that your skull is flat, but it's a very thin, flat bone, not a long bone like in your arms or your legs. In the arms and legs and fingers and toes and that sort of thing, you have what's called endochondral ossification, which is where a cartilage matrix is laid down during fetal development, and then that is slowly replaced by bone in the process of ossification. And most bones in the body form this way. All right. So if you start on the left side of this page and follow your way over to the right, you start with a cartilaginous model, which develops when the fetus is very, very young. It starts solidifying or ossifying from the middle out. And you can see there are chondrocytes here. These are the cells that produce cartilage, but then some osteocytes will actually start forming around that, and they make a collar around the diaphysis of the bone. You can see in the next stage, most of that has been ossified and become spongy bone, but the ends, which are still growing, are still made of cartilage. Eventually, they will begin to ossify as well, starting with secondary ossification centers. For most of, why did that do that? Sorry. I don't know what's going on here, but in any event, you can see you've got ossification at the top, in the middle, and in the bottom. But down here and here, there are 2 points where you still have cartilage, and these are called growth plates. And during your childhood, this is where your bones are extending from. So starting here and growing out, and starting here and growing down, all right, your bone actually grows outward from this location and this location. So either end is growing. Now, your bone, just like any other portion of your body, is capable of healing. And we call this bone remodeling. And it plays a very strong and important role in homeostasis, all right? Praise Jesus, homeostasis. We've got about almost 20% of your bone is renewed every single year. And remodeling allows your bones to respond to stress, all right? Gaining weight, losing weight, changes in body, pregnancy. There's a great deal of remodeling in your bones during pregnancy for those of you who carry a child. And in addition, the remodeling also allows for regulation of blood calcium levels. There are 2 hormones that are important here. Parathyroid hormone, which increases the blood calcium by accelerating this recycling process. It pulls calcium phosphate out of the bone and puts the calcium into the blood, whereas calcitonin does just the opposite. It decreases the blood calcium. It pulls the calcium out of the blood and builds new bone. All right, so parathyroid kind of takes apart the bone, calcitonin puts it back together. And again, this is a negative feedback, a balancing act of the calcium. Most of you have probably heard of the term osteoporosis, and although you oftentimes will associate this with older folks, grandmas and grandpas kind of people, osteoporosis can happen to pretty much anybody. It is a condition where bones are weakened because of a decreased bone mass. And typically after age 40, this is because the rate of bone reabsorption exceeds the rate of absorption. And so, in other words, you're pulling more calcium out of the bones than you're putting back into the bones. Folks who are most at risk of osteoporosis are female, although males can certainly get it. White or Asian folks, although African Americans and other folks can get it as well. Being very thin, having a family history of osteoporosis, early menopause, smoking, a diet low in calcium, so drink your milk and eat your yogurt and that sort of thing. Too much caffeine, too much alcohol, or just being a couch potato can lead to osteoporosis. Osteoporosis can be very dangerous, especially in older folks, because it can lead to fractures and other complications. And so, you don't want to be too sedentary. You want to keep those bones strong, especially as you age. There are treatments for osteoporosis. Certain drugs can mimic calcitonin and help the buildup of new bone material. Okay. Bones can be repaired. I mean, how many of you have ever broken a bone? I got to put my hand down because I never have actually. But bone repair occurs in 4 stages. The first stage is very quick. In the first 6 to 8 hours, a hematoma, or in other words, a scab forms. A clot forms between the broken bones, and you can see that located here. Notice the blood clotting underneath the periosteum level. Over the next 3 weeks, a fibrocartilaginous callus will appear to replace the hematoma. After 3 or 4 months, spongy bone will replace that cartilage, and then eventually the fracture will heal. There's always going to be a small bump in a broken bone where the bone was broken, and doctors and other folks can use that bump and how big or small it is to determine how long ago that bone was actually broken. Okay, so that ends our discussion for the first portion of this. And so we'll end it here and move on with the next video.